This is a wooden robot. A self-propelled little robot made of one material. It could transform the face of the planet. Literally put it on the ground. And it will slowly begin to bury itself. Attach a seed to it and it can its use. To replant forests all over the world. It's a groundbreaking innovative design. It might also play a huge role in energy. Harvesting soft robots and sustainable buildings. But what exactly is it? It was inspired to develop in starting with the structures of hygromorphs that change shape. In response to moisture like pine cones. That automatically close their scales when plants get wet. These types of structures are often used to change and modify themselves. In response environment. There is actually something that is very similar to this wooden robot. Indeed, there is a rhodium plant in nature. It produces fruits and seeds with a watery tail-like structure. Helps push it into the ground until it germinates. As the humidity changes in the environment is twisted and unwound. Trying to dig the seeds deeper. And while this plant was a major inspiration for this research, there was one major problem. And that was a success rate of erodium seeds for digging in the ground. Really low on some terrain. It even has a 0% success rate. So to improve nature's design, the research team decided to create a more efficient hydroform structure. Based on our calculations and simulation results. Having 3 anchor points. Points that prevent them from flipping over or falling over. So they always face down at a very specific angle, so that helps with the hit rate so much. Actually 5 sounds in our experimental results. So the coil numbers are kind of simulated. Using mechanical simulation so that the trade-off is you having more coils will soften the chassis the entire. But having a few coils will not have enough thrust. And the effect of the playback digging allows the bench to be placed safely underground where there is less chance of being eaten by an animal affected by fire or temperatures. Or simply washed out this time. Endeavor was a huge feat of science and engineering. With an attempt to engineer wood that has the ability to bend wide while also remaining strong. And harsh experiments were run for optimal number of file angles from entry. Wood bending. Sure, there's a ton of math and precision that went in to design this. When the design comes in contact with moisture, the wood expands. But the cells of the inner layer do it faster than the outer layer, causing damage to the robot when it dries later. It shrinks at different speeds. Again with the inner layer cells shrinking more quickly to push the seed into the soil. Choose oak wood because it is one of the strongest woods accessible. Also we have this series chemically treated and it is almost the same process as making paper. We did experiments with processing to make sure that wood is flexible at the point but not as easy to break as prolonged processing. Then we can enter the mechanical molding to be. This nut is a structure and it is the first of its kind to be made from a single material. 302 requires nothing modular, the benefit of using only wood. It's completely biodegradable so you don't have leftovers. With a bunch of trash sitting on the forest floor forever. Everything you can do, carrying seeds of to 75 milligrams in weight compared to the typical hydromorphic seed in nature, which typically holds about 8 to 20 milligrams in weight, opening up the possibility of 4 different types of reforestation because of the customizability of the design. The team was able to tailor it to fit different terrains. They also tested dropping seeds from drones in the air and managed to maintain a 90% success rate. For the optimal angle not only, but the research team was able to add symbiotic species on the robot including beneficial fungi and nematodes to increase plant health and overall survival rates in natural environments. But far about just planting more trees. The long-term effects are really cool. While there's been quite a bit of interest about soft robots, we actually made a video covering some of these new liquid robots. Wooden robots don't quite fit into the category Their kind of blends both soft and hard robots into new company class robots have the advantage of being able to interact with their environment like soil more easily, while having some shape-shifting properties. Soft robots. Pretty amazing. It's one type of energy to another, which is water and outer can sucking in a digging motion. It can be in other shapes. There are matter responds to heat and that transforms into other emotions. Maybe circular, maybe that random example. You could have a covered window. That kind of trigger, and once it rains, you can have some scale that opens and closes according to moisture out. Negative designs. Once built, we rely only on natural resources. It's a great example of biology-inspired engineering looking to solve problems using little tips from nature. Thanks so much for watching me. I hope you found this as cool as I did. If you like the video, make sure and subscribe for more science. We'll see you soon. Peace. This little device can reforest the entire planet.